So let's say I have this equation where I'm looking to solve, let's say that this is equal to 0. And I'm looking to solve this equation. What happens is I end up not being able to separate this. Let's try dividing everything by x. So I'm going to divide each term by x. And I'm going to get 0 equals x. That's great. That's 6. That's great. But then this thing gets all 2 over x, and that's not so good. If I chose to not do that, but instead chose to do the following, let's subtract 6x from both sides and divide it by x. I still end up getting this 2 over x thing, which is not good. And so what ends up happening, let's even just subtract 6x from both sides and then subtract 2 from both sides and then take the square root. Well, I can't take the square root individually of these things, so I end up getting x equals the square root of negative 6x minus 2, which is not good either. So none of that's very good. Some of you might have the instinct to do the following. You're going to subtract 2 from both sides and then factor the right-hand side, which is great, except I'm going to try to figure out when x plus 6 is equal to negative 2. No, because that doesn't matter. I don't care when this is negative 2. I need to know when all of this is negative 2. So that factoring thing only works if you have 0 on the other side, or if your equation is set equal to 0. And that allows us to create independent factors. So none of that works. If I had this kind of thing, 64, I could take the square root of both sides and get x equals plus or minus 8. That would be wonderful. And that's what completing the square does for us. Completing the square allows us to get a more complicated term, not just that x, but I'll get something squared equals some value. And that's what completing the square allows us to do. So how do we do that? So what we're going to do is I'm going to separate this and create a bunch of space. So let's go x squared plus 6x. Now typically I subtract it from both sides, but I'm going to do it like pretty much every other teacher does. I'm going to create a bunch of space there. And so this is the same equation. It's just a bunch of space in between these two terms. And what I'm going to do is I'm going to find out what number I can add right here so that this thing can be factored. Now visually, this is what's going on. I end up having something that I erased. I end up having this like box, and if I take x and x, the area of this is x squared. So this represents the first term, right? And then this has a length of 6 along this side and x there. So this has an area of 6x. That represents this term. I'm not concerned about representing this term because that positive 2 is not involved with completing the square. So to complete the square, I'm going to take this 6x and I'm going to take half of it and move it up here. Such that this has dimension 3, this still has dimension x, so the area of this is 3x. This now has dimension 3, and this has dimension x, so this is 3x. So this, even though they're placed in different locations, these two rectangles are equivalent to that 6x rectangle. Okay? So my areas are still equivalent. Hopefully you're in agreement there. So completing this square is really doing the following: figuring out what I can add here, what area I can add there, in order to see how we're physically completing the square. So if I can figure out the length of this, 3, and the length of this, 3, then I get the area of this guy, which is going to be 9, because it's 3 times 3. So how do we do that analytically so we don't have to draw this picture all the time? What you end up doing is you end up taking this 6x, and just like we did physically, you're going to divide it in half. You're going to get 3. You're going to take the coefficient and divide it in half and get 3. So that's 6 divided by 2 to get this 3. And then you're going to take this 3 and you're going to square it to get plus, I wanted to do that in blue. You're going to get this plus 9. All right? And I'll show you how that lines up. But in the meantime, you just added 9 to the right-hand side of the equation. That either means you have to add 9 to the left-hand side of the equation or subtract 9 on the right-hand side. Because plus 9 and minus 9 equals 0, I effectively have not changed my equation. So let's clean this up a little bit. 0 equals x squared plus 6x minus 9 plus 9. And I'm going to take this and I'm going to factor it. And hopefully you see that it's going to factor into two binomials, x plus 3, which then I can write as x plus 3 squared. This minus 9 is still there. This plus 2 is still there. But once I add those, I get negative 7. And so I've just completed the square. I turned this non-perfect square trinomial into a perfect square trinomial such that I can write it this way. So then watch the math that I can do. If I add 7 to both sides, I get 7 equals x plus 3, the quantity squared. Now I can effectively take the square root of both sides and get x plus 3 equals plus or minus the square root of 7, and subtract 3 from both sides and get x equals negative 3 plus or minus the square root of 7. So there are two answers there. All right? Two answers. So that's completing the square. Let's do another example that's a little more complicated because it has some fractions going on there. So x squared plus 5x plus 4. X squared plus 5x plus 4. Sometimes in the software you're going to be given an equation, a function, for instance. This is a quadratic function. And you're going to be asked to find the vertex. And so you'll find the vertex of this by putting it into vertex form. And so you won't have a 0 on the left-hand side. Doesn't matter. If I take x squared plus 5x, create a little space here, add 4, and then I can do the following. I know that what I'm going to end up with is going to be a perfect square trinomial. So these two binomials will be the same. And I'm going to end up, because of the same, I'm going to end up being able to write them like x plus some number. X plus, and what's that number? In this case, I'm going to take the 5 and divide it by 2. And so that's what it's going to look like. That's my squared binomial. What do I add? Well, I have to take 5 halves and square it, which means 5 halves times 5 halves, which means I get 25 over 4. And so I'm going to add 25 over 4 to the right-hand side of the equation, which means I'm going to have to subtract 25 over 4 from the right-hand side of the equation as well. Or again, you could add it to the left-hand side. So that means I have a plus 4 minus 25 over 4 right here. And if I take care of that math very quickly, I really have 16 over 4 minus 25 over 4, which is negative, what is that, 9 over 4. So I have minus 9 over 4. And so that's my function. Okay? And what's the vertex form of the parabola? Vertex form of the parabola is a times x minus h, the quantity squared, plus k, where h and k form the coordinates of your vertex. So this is your vertex. And so that's why we want to complete the square. The structure of completing the square after you complete the square is the exact structure of the vertex form. So in this case, our parabola has a vertex of negative 5 halves, comma, negative 9 fourths. Okay? So that is completing the square, and that's the vertex form, and that's how you can determine the vertex. And how do you find the x-intercepts of this? Because it is one of the questions you'll be asked. You use the same formula. The x-intercept is defined as are the points that have a y value of 0, because they're on the x-axis. So if I set q of x equal to 0, set my function equal to 0, and then solve for the x's for that 0, then I will have my function, or my x-intercepts. So now I'm going to add 9/4 to both sides. So 0 plus 9/4 is equal to 9/4 equals x plus 5/2, quantity squared. Take the square root of both sides. I'm going to get x plus 5/2 equals plus or minus the square root of 9/4. But the square root of 9/4 is 3/2, because the square root of 9/4 is equal to the square root of 9 over the square root of 4, which is equal to 3/2, plus or minus. Now I'm going to subtract 5/2 from both sides. And so I'm going to get x equals plus or minus 3/2 minus 5/2. Or if you prefer, 3/2 minus 5/2. I think the textbook's going to want this done out. So I get negative 2/2, which is negative 1. And then negative 3/2 minus 5/2, which is negative 8/2, which is equal to negative 4. And so my x-intercepts are negative 1, 0, and negative 4, 0. Okay? So that's completing the square. Good luck.